This is tutorial number 119, and it covers the spline definition within Solidworks. So to start off, let's open up a new part file. Let's click File, click New, click Part, click OK. Now in this tutorial, what I'm going to do is I'm going to give you a brief, definition of what the spline tool actually does. So let's just click on Tools right now, click Sketch Entities, click Spline, click Any Plane, and if you've not already used it, what you can see is that every point, it automatically creates a profile. It follows it to the best degree that it can, going all the way around. So what I'm going to do is just kind of show you a brief little definition of how it works and why it works. Okay? So this is from one of the lectures that I've had going through engineering, and this is just kind of like an example just to show you like a reasonable and an unreasonable spline definition. So they both have the same point coordinates, but the difference is that as you're going around, one is reasonable and one is unreasonable. This one's unreasonable as it's shooting up all over the place. So really, you're not getting the true spline that you want. This one, it goes around, it curves around, and that's what you want. Now with a spline, each point, in between each point, each two sets of points, it's actually a different kind of function. So in here, this is function, we'll call this function x, function f, this can be function g, h, I, j, k. Each of those is a separate function, and they're totally different from one another. So this can be, just as an example, this one could be x squared, this one could be x to the power of 3, 2x to the power of 4, whatever. They're unique to one another, but you're only getting a segment of each of them. And when you get just that segment, that's what gives you the spline, so that at each, the real, key to the spline is that at each point, the transition point between the two different functions, at that point, they're the same number. So, say this is at point 0.5 here. At point 0.5, function h is the exact same as function g. So when they're at 0.5, they're the same, and you get a nice transition. So when you have something like this, it's not really true. Even though they do touch the points, it's an unrealistic spline. Now, doing the spline, if you just Google it, you can actually find there's many different ways that you can manually calculate the spline. But if you're doing it on SolidWorks, it automatically, you plot in points such as these, and it'll automatically go and do it. So if we go into Paint, I'm just going to show you a couple examples of kind of like what a different spline, what it's going to do. So say we had, say this is like the Y, this is the X, and say we have points going up just like this. If we have those points, and we'll change this to yellow, we're just going to get pretty much a straight line going right through them. But if we have points such as this, we need 3 different functions here, since we have 4 points, to fill up and to create the function. So I'll just kind of freehand. So we can say it's going to look something like this. But if we go to the yellow, let's say this is our first function. This function really actually continues, such as that. This function here is really something like that. And our last function there, we can say something really like this. So you can see that we're kind of like cutting out patches of different functions and putting them together. So that's pretty much what the spline definition does. So if we go into SolidWorks, if we plot like a straight line, we're gonna, like points on a straight line, we're gonna get a straight line. So let's exit this. New file, and let's just do a spline in a straight line just to show you. So if we make all these points in a straight line, they're going to be straight. Now, if we veer off course and give it another point somewhere else, it's going to go outside. So that's just like a basic overview of how the spline works, how it takes certain points and it inserts functions in between 2 points and kind of blends them all together. So that's pretty much like the definition. If you want to look more, get into it more, you can go onto Google. You can find the different ways of, I guess, mathematically, if you wanted to do a hand calc and find out yourself how to add and how to put a spline together, you can do that. But I'm just kind of giving you the overview just so you know that when you're putting in these points, that's what it's going to do. So that concludes our tutorial on the spline definition within Solidworks. This is tutorial number 120, and it covers how to apply the Spline Sketch feature within Solidworks. Now to start off, let's open up a new part file. Let's click File, click New, click Part, click OK. Now, the last tutorial I kind of gave you like a definition of how the Spline feature works, how it's run, and just so you know when you're putting the points in, how to manipulate it to really get what you want and to get the function out of it, what you want it to look like. So in this tutorial, I'm just going to show you a couple quick things, how to manipulate it. So to start off, let's click Tools, click Sketch Entities, click Spline, click a plane. Now just draw out first just a random spline. Now with a spline, it's going to make you keep going, and then say I stop here, and I want to stop here, you right click and say End Spline. It's just going to end it, and you're fine. Now, to kind of just skip that step, you can go around and say, I want to stop it at this point here that I'm coming up to. Just double click, and it stops automatically. Okay. Now, with a spline, you can do it as a function, just like a little bit like that, or you can actually bring it around and complete it. Now, let's blow these away. So just click X and discard them. Let's do some more splines. Now, just draw out again a random spline. Now, there's a couple ways of manipulating and moving your spline around. So, if you see that at each point we have these arrows or these lines, what you're able to do is either able to move it degree-wise like that, or you can pull it out your spline. So, you're able to go in and manipulate it and just make it your own. Make it what you want to see, how you want to see it. Now, if you click OK and click End Spline, click Select, and if you get back into it, you're still able to adjust some of the parameters on here. So when you're flipping through here, it's telling you which point you're on. The first point, you can't do anything. It's set at the origin. Now we're at the second point here. So if we start increasing it, it's going to move around. So it's pretty much what we're doing with these guides here. You're able to be much more precise and just do it within this view here. So you're able to really input the right coordinates and what you want. And then each time you move it, now we're at the third point here, so move that guy around. Now we're at the fourth. You can move him around. So you're able to just move it around and play around with it there. Just click OK. And if you don't want to do it like that, you can also use a smart dimensioning tool and just dimension the distance from each point. So say you want this one to be 60. Do it. It moves to 60. So that's just another way of dimensioning your spline there. Click OK. And click OK again. And now you have your spline. So you're able to go in, either if you have like a mathematical function that you want to put in with the right coordinates and points, you can do that. Or you can just throw it in, just play around with it, move it around yourself, and then you'll get your spline. And that concludes our tutorial on how to apply the Spline Sketch feature within Solidworks. This is tutorial number 121. And it covers how to use the Spline on Surface sketch feature within Solidworks. Now to start off, let's open up a new part file. Let's click File, click New, click Part, click OK. So in this tutorial, we're going to be covering how to use the Spline on a surface sketch feature. And what that does is it creates a 3D spline sketch on any surface that you have. So you don't have to create planes. You don't have to choose a plane to start sketching on and then use like a 3D sketch to move it around or anything. All you have to do is just click on the tool and click on any points on that surface. So to start off, we're going to create kind of like a unique surface that to sketch our 3D spline sketch on. So let's click sketch, click line, and just click any plane. Draw one line straight up, and then with a 3-point arc, just make a unique little design. Something with different surfaces, and just play around with it. Click OK. And now with the features, let's revolve it around. And we're going to revolve it around that axis there. Click OK. And now we've got just an object with curved surfaces, and if we wanted to sketch on those surfaces, it would be very hard. So let's click Tools, click Sketch Entities, and let's click Spline on Surface. So now just look at it from the front view, and just start clicking and making your spline. And if you move it around, you can see that that spline's on the surface of that object, and it moves with the object around the surface. So we didn't have to use a plane or anything, and it just goes around. Now, the one drawback though is if we click a point here, another point here, and try to bring it onto that surface there, it doesn't work. So whenever there's kind of like a line, it's kind of like a breaking point between your spline. So it needs to be on one continuous surface. Okay, and whenever we do it, you can see that it follows a curve, it follows the surfaces, and you don't need to select anything. You just start picking points, you know where you want them to be, and it goes onto that sketch. And then when you're happy with them, like any other sketch, just get out, and you've created your sketches. And that concludes our tutorial on how to use the 3D spline on surface sketch feature within Solidworks. This is tutorial number 122, and it covers how to use construction points within Solidworks. Now to start off, let's open up a new part file. Let's click File, click New, click Part, click OK. So in this tutorial, I'm going to show you how to use some construction points. So I'm going to show you with the center line and the point, just how to throw them in and how to use them as a construction point. So start off, let's click the front plane, and let's click center line. Now, with a center line, whenever you draw it, you're going to notice that compared to a normal line, it's got the, it's broken up into like little sections. It's got the dots going along. So the reason why you throw one in there is for two reasons. One is that that line's not going to be extruded or created when you make a feature from it. It's just there for reference purposes. So when you have the dotted lines there, it's just a reference line. So you're able to, say, add another line in here, and with a smart dimension, say, create an angle between the two, and say 45. So this is not going to ever be shown up in a feature, but this will be used in a feature. So that's the reason why you'd want to throw in a center line. And it can also be like a center line in whatever it is that you may have. If you have like a circle that you're drawing or something, you can throw it in as a center line too. But pretty much a center line is just like a construction line that you can put it in there, and it's not going to show up when you create the feature, but you're able to dimension and parameterize everything else around it. And it's kind of the same with the points. If you put in, just say, a couple of points around here, you can use those to reference other things around. So let's make it 150. So even though this is already dimension is kind of pushed there, but say we threw in some points and it already had constraints on it, we can use those points then to constrain the rest of the sketch. And then say we like our points and the positions that they're in, then you can go and fill it out and say, let's close that one up there, and we want a couple lines here. So with the points, you can kind of put them in beforehand, measure them out to the points and the spots that you want them to be, then fill it out by using the line, 3-point arc, whatever sketch tools that you wanted to use. So it's a nicer way rather than kind of drawing that same thing in and then trying to go back and playing with the points and stuff, because then it's a little bit more finicky. So if you do the points alone and you put them in the right positions, it's a lot easier and it's a lot quicker than drawing a sketch and then trying to parameterize the points. And that concludes our tutorial on how to use construction points and lines within SolidWorks. This is tutorial number 123, and it covers how to insert a sketch plane in a sketch within SolidWorks. Now to start off, let's open up a new part file. Let's click File, click New, click Part, click OK. So in this tutorial, I'm going to show you how to insert a sketch plane while you're inside of a sketch. So the reason why you'd want to do this is if you have one sketch that you're making, and say it's like a 3D sketch, and you've kind of like made a certain part already to it, and you want a certain plane, certain positioning, so you're able to add another sketch plane that you're just going to be sketching along in that sketch without going out of it, creating a new plane, and creating like a brand new sketch. So you'll kind of have everything in one sketch rather than having it in two sketches. So to show you what I mean, what we're going to do is we're going to kind of create the part that we made in the spline on surface tutorial. So to start off, let's click line, click front plane, make a line going straight up, and then with 3-point arcs, again, make just a unique little surface. Click OK. And let's click Features and Revolve Base, and let's just revolve it around here. Click OK. So now what I'm going to do is I'm going to be sketching 3D sketches on the surface using the spline, and then after doing that, I'm going to insert the sketch plane on there so that we're able to sketch just on a certain plane of that sketch. So let's click Tools, Sketch Entities, Sketch Spline on Surface. So let's look at it from the front and just create your spline on the surface. Now, if you look out, you can see that it's going around the surface. Now, if we go to Tools, Sketch Entities, Plane, or if you just click the plane here, it's up to you, we can put a new plane in. So right now it's referenced off of this spline, so you can make it perpendicular, tangent, whichever way you want it to be, and you're able to add different references. So right now it's just referencing the whole spline, so using that whole spline, you're creating a sketch in there. So say you want that, it looks good, let's click OK, and now you have another sketch plane in there, and whenever we're sketching, it's going to be along this new plane that we just created. So you can also throw in, say, like some points. So say that there's a point there. We have to get out of this one, so let's click X. We don't want to save it. So let's do another sketch, and we'll do another 3D kind of sketch. So let's get the spline on surface, and we'll start sketching a little bit over here. Accept it, and let's do another one. Click OK. Now let's click the plane, and now it's going to ask for 3 separate references. So now that we have 3 different splines, we can click different points on them and try to make it. So we have that point there. Say we want that point in it too, and we want that point in that spline. Now we like it. It's for whatever purpose it is. That sketch plane is the one that we want, so let's click OK. And now we have the sketch plane using those points to sketch on, do whatever it is that we need to do whatever we want. Let's click OK. We've got our sketch. So these sketch planes, as they're kind of like dotted lines kind of thing again, you're not going to be able to set like really parameters off of them kind of thing. So if you put it into an assembly, you're not able to configure for, say, this plane to be perpendicular to whatever surface or whatever it is. So these sketch planes are just kind of like for in here, So you can have either one feature that it's going to just make the plane off of, or if you have three unique points, it can be from previous sketches too. It'll create a sketch plane from those. So that concludes our tutorial on how to use the sketch plane feature within Solidworks. This is tutorial number 124, and it covers how to use the Convert Entities feature within Solidworks. Now to start off, let's open up a new part file. So let's click File, click New, click Part, click OK. So in this tutorial, we're going to be covering how to use the Convert Entities sketch feature, and what that does is if we have a plane, or say like a surface that we're sketching off of, and if there's features or lines or a sketch that is not on that plane, it's somewhere else in the part or in the sketch, and we want those lines to come onto our sketch, we're able to just use the convert feature, and it automatically converts it to there, and then it also moves it around to the right orientation and everything. So it's kind of hard to visualize right now, but I'll show you an example here. So to start off, click Sketch, and we're going to sketch out a cube. And let's make the cube 50 by 50. And then let's extrude it out 50 mils. Click OK. So now what we're going to do is we're going to create some planes that are kind of offset and a little quirky from like normal, I guess like what we have, like front, top, right plane view. We're going to make some on a few angles. So let's click this face here, click Insert, click Reference Geometry, click Plane, and let's make this 30 degrees, and click this line here so it's going to move around that point there. Click OK. Now let's also move this guy out a bit. So let's do another reference plane, and now he's moved out about 100 millimeters, and that's good. So let's click OK. Click this plane, and let's click Sketch. Now, let's say that we're sketching on this plane, and we want this whole profile of the square to be on here, because we want to extrude or do something with it. Now, if we went and just tried to draw it ourselves, we're not exactly drawing it precisely to what it should look like. So what we want to do is just extract those lines and those points and put it on our sketch. So if we click Convert, and let's click this line here, it converts and it goes right onto our sketch. So let's do that for the rest of the lines. Let's click this line, click Convert, and we'll hide this plane so we can get the last line there. And now we've converted all those points onto here. Now, if you remember, our square was 50 by 50. If we go to dimension this right now, that's 43. This is still 50 on the side. And why it's moved around is because of the angle that we're looking at onto the object. So let's delete these features. And now, let's say that we wanted to extrude this. This is going to extrude directly onto those 2 points, like onto these lines. So when we go to extrude it, it's precisely in like the right orientation, the right direction and everything. So it works out very nice when you convert entities. So let's click Feature, click Extrude, and let's flip it around just so it goes through. Click OK. And you can see that as we extracted those points out of the sketch, it came out perfectly from our extrude. It went perfectly into our original solid that we came out with. So you can use this when you're either in a sketch such as this, if you're in like a part and there's different planes that you're working off of, you're able to extract and pull from other parts and planes. So using this convert entities, it's just kind of like you're at a view, and then you can pull all those lines onto your view, and then you can play with it. And all those lines that come onto your view are directly perpendicular to like what you're seeing. It's what you're seeing, you're pulling straight out. So like I showed how the 50 mils turned into the 43.3, that's how much of the line you're actually seeing at that plane and at that view and that orientation. So it's a wonderful feature to pull out other features from other parts, components, sketches. And that concludes our tutorial on how to use the Convert Entity Sketch feature within SolidWorks. This is tutorial number 125, and it covers how to use the Face Curves feature within SolidWorks. Now to start off, let's open up a new part file. Let's click File, click New, click Part, click OK. Now what we're going to be doing is we're going to be using the Face Curve Sketch feature, and what that does is whenever you have like a solid, and if you click the Face Curves feature and then click on one of the faces, it's going to kind of give you a grid with lines drawn of the contours and the face, so then you're able to use like those lines and those contours to create other sketches or do whatever else you would want to do with it. So to start off, to show you an example, what we're going to do is we're going to create a little part to find our like sketch curves off of. So let's click Sketch, click Rectangle, click Front Plane, let's draw out like a square, click OK, and let's extrude it out, say 100 mils. Click OK. Now click the top face here and click Sketch, click 3-point arc, and just make one on the side here. And let's make the dimension in between here. Pull it out so it's about 70. Now put a line down there. Click Feature, Revolve, and revolve it around that center line there. Click OK. So now what we're going to do with the face curves is we're going to create kind of like grids on all these different faces. So click Tools, click Sketch Tools, and click Face Curves. Now all you have to do is click any of the faces and it's going to give you like a grid. So let's click this face here to start. And you can see that we have a grid. And you're able to control the grid by all these points here. So usually it's at about 5, 5. So you can play around, move it up, move it down to whatever it is that you want. So right now we're on Mesh. If you use Position, you can play around with that. Like it's up to you how you want to do it. You know, you play around with it. It's going to give you pretty much like one line and one line there. I like the Mesh. I think it looks pretty cool, especially when you do it on curved surfaces and stuff. And plus, when you get more of these out on there, it gives you a nice feel, and you can use all of them to do whatever it is that you want to do. Now, let's try it on the curved surface. And for the face curves, it's a lot better on curved surfaces. Like on a square such as this, when you sketch on there, it's a lot easier to find your points and find your lines. But on a surface like a curve, like a circle, or an ellipse, whatever it may be, it's a lot harder. So let's click Face Curves, and let's click on the circle, and you can see that we're getting all of the lines all the way around there. So you can play around once again with how many you have. It's all depending on where you want to see it and what you want to do with it. Let's click OK. And now you have all the lines on there. So you're able to select one of the lines, say extrude out with it, do whatever you want with it. So it's up to you, and that's how to use the face curve surface. So you can see also on the side that each one of those is a 3D sketch. So you're getting 3D sketches from them, and you're able to derive from those sketches and play around and do what it is that you want. And that concludes our tutorial on how to use the face curve sketch feature within SolidWorks. This is tutorial number 126, and it covers how to use the measure command within SolidWorks. Now, the measure tool is this tool up here, the measure, and the advantage of using this rather than using, say, something on the sketch like the smart dimension to come up with your measurements is that this one will give you much more detail in your measurements, and it's a lot easier to use with if you have different things, like if you're in an assembly, if you have a part, different sketches and everything. So using this tool is the best way to measure everything within it, and you're able to measure something simple like, say, from this point to see how far that line is, or something more like from this point to this point, and it'll show you in more detail than just doing like a smart dimension grab. And it'll also let you measure a single point and where it is in the coordinate system. So to start off, let's click the measure tool, and let's measure just this line here. So you'd click this point here and this point here, and you can see that it's a distance of 100 millimeters. Now, let's get out of it, and we'll do another one. So let's do from this point here to this point here, and you can see that it gives you much more information than just a normal like smart dimension or something else would do. So it's going to show you the distance from point to point, and then it's going to show you in each direction. So the d, the dz, dy, and dx. So you're able to see in the z, y, and x direction how it's changing, how it's moving. So doing this allows you to see much more detail what you're doing, where you're going, and how everything's being affected. Now, you're also able to do surfaces. So let's measure, say, this surface to this surface, and it shows you the distance. So it's not just limited to points. You can do faces, and also show you you're able to do lines. So let's measure that line to that line. And again, it shows you the distance, and then it shows you in the y and the x. So it shows you pretty much how it made the triangle to get there. So that's your hypotenuse, and then, your two sides to make it. So that's the advantage of using the measure tool in here. It shows you in much greater detail, not just the distance, but how you get there, like in the y and the x direction, just so you have a bit more information to go with, and you can make more adjustments to your part, your sketch, and everything like that. And one other key tool with it that I like is when you click on one point, let's say this point here, you'll see that it gives you the box. It says where it is in the coordinate system. So it's x, y, and z direction. So that point has a coordinate of whatever it shows right there. Now, this is important when some assemblies, with bigger assemblies, with companies, I deal a lot with like the automotive industry, and what they do is they don't really use constraints in their assemblies. Most of the time, it's a positioning constraint. So, say I'm working on a door panel or something. When I click on a point on the door panel, it's not going to be a small dimension like that. It's going to be, x away from the front left tire or something like that. There's an origin with like the whole vehicle, so that when you're in the position, when you're in the assembly, it's actually position constrained. So all the parts, it's hard to kind of visualize, but every part has like a position in the assembly. None of them are really constrained, like using the assembly constraints, like being coincidence constraints and whatnot. Usually they just use positioning constraint. So using this tool, you're able to see where you are in the position. So even though the coordinate system's here and the part's here, sometimes when I'm working on a part, this is the part here, but really the coordinate system is down here and it begins. So it's a much larger dimension that you get all over. So this tool also lets you see where, in the whole grand scheme of things, where your part really is, if you select just a point. And that concludes our tutorial on how to use the measure tool within SolidWorks. This is tutorial number 127, and it covers how to use the mass properties feature within SolidWorks. Now, to start off, all you have to do is just extrude out a shape. So I've just done a square and I've just extruded it out. Doesn't matter what it is, just make an object, extrude it out, just so you have a solid to play with. Now, to use the mass properties feature, it's all up here. So you click here, and you click on mass properties. So let's click on it. And it shows all the mass properties right here. So it's going to show you the density, the mass, the volume, surface area, center of mass, and it's going to show you some inertia values too. So by using this, you're able to apply it to your design. You're able to see something, say like the mass. You need to keep it to a certain mass, the object or the part. You're able to adjust it through here. Now, if we get out of this right now, it's in millimeters, and so that's the metric system. If you want to change it to the imperial, all you have to do is go to Tools, Options, Document Properties, Units, and change it to inch, pound, second. Click OK. And now when we go and click the mass properties, everything is in pounds, inches, cube. So now we have everything in the empirical compared to the metric system. So you're able to adjust it like that if you want to see it in pounds compared to kilograms or whatever. So now, right now we don't have a material specified on here. So let's specify a material and just see how it changes the mass. So right now the mass is 0.69 pounds. So now let's right click on material and let's apply 1060 alloy. We'll do the material, the mass properties. And now you can see it weighs 1.86 pounds. So when you're changing the material, you're able to see instantly like the results of your material change in the density and the mass. Now the volume and surface area, of course, are going to stay the same, and the same as the center of mass, it should stay the same. Now let's change it one more time. So remember, 1.86 is the pounds. Let's change it to brass. And let's do the mass properties. And you can see now it's up to 5.86 pounds. So by changing the material, you're able to see how it affects the properties of the part that you have. So by doing this, you're able to optimize your mass, your volume, your surface area, and you're just able to see really what's going on with the part. So if you have some certain, I guess, parameters that you have to make your part in, you're able to apply the mass properties to see really what's going on. So if you need to keep a certain part to a certain size using a certain material and a certain mass, this is the way to go just to make sure that everything's going fine. And that concludes our tutorial on how to use the mass properties feature within Solidworks. This is tutorial number 128, and it covers how to insert equations into Solidworks. Now to start off, let's open up a new part file. Let's click File, click New, click Part, click OK. Now what I'm going to show you is how to add equations into the part so that you're able to use these equations as you go along, or just to have them in the part just to kind of show people what you're doing and where you derived a certain parameter, distance, whatever it may be. Okay, so to get to the equations, click here and then click Equations, and now you're able to add equations into here. Now one thing that you need to look for is if you're using like the sine or cos, you have to know that if you're going to be using degrees or radians. So I'm just going to leave it to degrees right now. So to get in, click Add, and now you're able to add an equation. So I'm just going to show like a simple one. I'm going to do 12 times x equals 5. Click OK, and now it's added that equation. And if you click OK, you're going to see that there's an equation box on the side here. Now when you go to open it up, it's going to show that equation. So now you have this equation with the part, so you're able to apply it to the part, and it's able to move around. If you send this part to someone, they're going to be able to see, okay, this dimension came from this equation using this formula and whatnot. Now you're able to edit it. If you right click and click Edit Equation, you can go in and edit it. So let's do another one now. Let's do sine 45 times bracket 3 times x to the power 4 equals 10. Click OK. Click OK, and now you've updated that equation. Now when you're doing equations, you have to make sure that you have that it equals something at the end. If you say do this, it's still sort of like the same equation. If you click OK, it's not going to accept it. You have to have it to equal to something. So even if you have it equal to 0, it's still going to accept it. So that's the way to insert equations, and you can do multiple ones. So we have that one right now. Let's insert another one. So we'll click Equation, click Add, and let's do tan 30 times 7 equals 12. Click OK, click OK, and now we have another equation there. So you're able to add like a bunch of equations that you'd be using in the part, or just to show people when you send it out to whoever it may be, just so they see what's going on. And that's how to add equations into SolidWorks, and that concludes our tutorial. This is tutorial number 129, and it covers how to look at statistics of your SolidWorks part within SolidWorks. Now to start off, let's open up a new part file. Let's click File, click New, click Part, click OK. So what we're going to look at in this tutorial is statistics of your Solidworks part. Now these stats that we're going to look at are going to show how many solids, how many features, and how many surfaces you have going on in your part. And this just lets you know pretty much kind of like how big your part is, what's going on, what's taking time to rebuild it, and it just lets you kind of see in another way how everything's being put together of your part. So to start off, I'll show you where, well, first we're going to extrude just like a basic part out. So click Sketch, click Rectangle, and we're just going to extrude simple square out. So just extrude it out, make it say 50, click OK, and now we have just our first basic part. So to get to the statistics, we have to click here, click Statistics, and now it's going to show you that there's 2 features, there's 1 solid, there's no surfaces in this part, and the whole time it took to rebuild it. So that's kind of like how long it takes for all the mathematical processing kind of going on behind the scenes to create the part, open it up, kind of stuff like that. So if it's at, like it is right now, 0.01 seconds, it's a very easy part to open up, it's very easy to rebuild, so everything's looking good right now. So let's close this. Now let's add another feature to the part. So let's click this face, click Sketch, click Circle, just draw a circle and extrude it out. Click OK, and now let's do the stats again. So let's click it, and now you're able to see that there are 4 features now, 1 solid still, 0 surfaces, and the total time to rebuild it was 0.01. So still a quick solid to make. So the more features and more parameters you put on, the more things that are going to show up. So let's add some more features to this. Let's click the fillet, and let's make a bunch of fillets all the way around. Mix it up a bit, change what sizes you're doing. Just make it interesting. Here. So right now, just add some dimensions. This can be a previous part that you have too, that you want to just look at the stats of it. So whatever, I've done a few more changes to the part. So now let's look at the stats and see what it says. Now there's 8 features, still 1 solid. And this, now the time's gone up to rebuild because there's a lot more going on. So now the time's 0.25 seconds. This is going to be different for every computer too. If you have a really fast computer, it's going to take a lot less time. If you got a slower computer, all these features might be taking you a lot longer. So you have to gauge it kind of thing on your own computer and see how it's going. Mine's moderately fast. It's not super fast, but it's not slow. So this is probably, say, like an average time across the board. And now also you can see, as you go down, the time spent on each individual, I guess, like feature to rebuild it and create it. So what's taking the most time right now is this fillet. So when you have a lot of features, and say you're running into problems, if you go into this statistics, if you go and you can see which part is taking the longest to rebuild, there may be a problem with the part. So if your total rebuild time is, say, 5 seconds, everything's at, like, say, 0.01, 0.02, and then you have one part that's taking 5 seconds, there may be something wrong with it. So this allows you to kind of pinpoint a problem in the rebuild process, so you can go back and you can adjust what's going on with your part. And that concludes our tutorial on how to look at the statistics of your SolidWorks part. This is tutorial number 130, and it covers how to use the Deviation Analysis tool within SolidWorks. Now to start off, open up part 130 that I've included on the DVD. Now you can use this part or you can use one of your own. All that I really want to make sure that you have is a line like that through a fillet and just some other edges that you can select. Now what we're going to do is we're going to use the Deviation Analysis tool just to give us a better representation of the lines, just to like show what's going on with them. So to access it, let's click here and click the Deviation Analysis. Now if we click a line such as this, and we press calculate, it's going to show you the deviation and just really what's going on with the part, with it being straight, or if it's like an edge, if it's curved, if not. So if you see too many of these arrows too, you can change the number of them. We can go back, calculate it again, just so you can see a bit better. So really, this is showing on the side here, I guess like the angle. So right now, the max deviation's about 90.02, and the min's 89.98. So what that's kind of saying is that it's a right angle, and that's like the curve. So like the max that you're gonna get and the lowest that you're gonna get. Now, if we unselect this edge, and if we do a curve such as this, and if we calculate it, you can see that we're getting all the way from 0 to 90. Now, if we get like a 0, that's going to be a flat line, such as this one here. If we delete this one and calculate it, we're getting zeros. So a 0 is pretty much like a flat line on a face that's not really doing anything. And a 90 is like 1 on an edge, so that you have kind of like a 90-degree angle going on there. And with this guy, it's pretty much like a 0-degree angle. So it's kind of flipping it around. If you think of this as like a 90-degree edge, and if you think of that as like a 0-degree edge kind of thing. So that's what it's doing. It's analyzing kind of like the edges and seeing where everything's going. Now let's delete these two, and let's take a look at this curve again. So let's calculate it. And you can see that this one's like a transition from the 0-degree edge, that's just like a flat, to the 90-degree, that's like a corner. So as we have this fillet here, we're slowly going around those. So we have a max deviation of 90, like the 90, a min of the 0, like the 0, and then it shows you like an average deviation there. Now we can increase the number of lines again, or arrows, sorry, so you can see a bit more representation, just what's going on. You can decrease it, so it's up to you. The more you do, the more precise and exact, as it's using more points to calculate it all. And then you're able to edit the color just to see what your min and max is. So I can change this, say I want it to be black. Calculate it again. Now it's black is going to be my max, and say I want white to be my min. Click OK. Calculate it, so the black's the max, white's the min. Just another representation of it. So by using this tool, you're able to see kind of like curves, play around with it, see the deviation of like the lines and stuff. And it's just another way to analyze your sketches and your edges. And that concludes our tutorial on how to use the Deviation Analysis tool within Solidworks. This is tutorial number 131, and it covers how to use the 3D Sketch feature within Solidworks. Now to start off, let's open up a new part file. Let's click File, click New, click Part, click OK. So in this tutorial, I'm going to show you how to use and utilize the 3D Sketch feature. So pretty much what the 3D Sketch allows you to do is kind of flop around between which plane really that you're sketching on. So if you called each plane like an XY, like a XY, XZ, and a YZ plane, you're able to kind of toggle in between all those planes. So to start off, you have to click 3D Sketch and then click whichever tool you want to use. So let's just use a line. So let's click line. And now you can see under the cursor says XY. So I'm on the XY plane right now. So I'm going to draw a line straight up. And now I'm going to draw one straight across. And you can still see it's all on the XY plane. Now to switch planes, you have to rotate your views around. And now you can see that I'm on the YZ plane. And if I rotate it around again, you can see that I'm back to the XY plane. So by rotating your view, it rotates where you are sketching along. So now I'm back onto the YZ, and now I'm onto the ZX. So you're able to create a 3D sketch by moving around all those different planes. Now you don't have to make it all boxy like I just did. I did that just so you can kind of see an example, really, of really what's going on. So I'm slowly going across each plane, going up and around, and by using those different planes, I'm able to create a 3D sketch. Now let's click X here. Now with the 3D sketch, you can also use any of the other tools here too. So let me just draw a line on the XY. Now let me click 3-point arc. And let's move this around. So I'm still on the XY. Now I'll click this point, and now I'm onto the ZX. Now I can do another 3-point arc on the ZX. So you're able to move around. Doesn't matter if you're using a line, 3-point arc, rectangle, circle, whatever it may be. You're able to move around and on these 3 different planes and move around your sketches easily. So it's nice when you do this. Just accept. This is going to be most likely when you do a 3D sketch, it's going to be a profile. So you're probably going to put, say, like a circle there, and you're going to let it run across those that path there and make something, say, like a pipe or something. So by doing this, you're kind of making a path, and that's pretty much what the 3D sketch is there for. You can do other things with it, but for the most part, a 3D sketch is usually a path line that you want to follow all the way around. And that concludes our tutorial on how to use the 3D sketch feature within Solidworks. This is tutorial 132, and it covers sketch relations within Solidworks. Now to start off, let's open up a new part file. Let's click File, click New, click Part, click OK. Now, this tutorial is just kind of a intro to the next few tutorials that we're going to be covering, and that's going to be going over all the different relationships when you're creating a sketch. So I'm just going to show you quickly the menu that we're going to go into. So I'm just going to draw a couple lines. And what we're going to be doing the next few tutorials is using this button, the add relation. And using this add relation, we're going to be covering a bunch of different relationships that we can add into the sketch. So these next few tutorials, we're going to be covering some of these parameters listed on the side here, and we're just going to be going over them and a few applications of them while you're actually sketching, and just to see the results and where you can go with it. So that concludes our tutorial, and the next few will be covering this. This is tutorial 133, and it covers horizontal sketch relations within SolidWorks. Now to start off, let's open up a new part file. Let's click File, click New, click Part, click OK. So what I'm going to be showing you in this tutorial is how to use the add relations and how to use the horizontal relations within a sketch. So to start off, let's start sketching a few lines. So let's click Line and click any plane. So draw your line kind of on an angle, just off to the side, and end the chain. Now we're only going to do one line at first, so let's click Add Relation. And what you can do is, there's 2 ways to go about this. So I'll show you one way this time. Click this line here, click Horizontal, and then it's going to give you a horizontal line. And these lines, when you're doing something like horizontal and vertical, they all come from like the sketch plane that you're looking at. So even though, say, it was on an angle that you're looking at it, that really is horizontal to the sketch plane, which is like your X and Y. So this is going to be horizontal. It's going to be parallel to your X plane, your X line. So that's one way of doing it. So let's click OK for that. And I'll show you another way of doing it. So put another line on an angle, click Add Relation. Now the line's selected, so let's deselect it. And let's click this point here and this point here. Click Horizontal. And now you've made a horizontal line. So you don't have to just do it by the actual line. You can do it by the points that are on the line. Now, it's horizontal doesn't just apply to lines. You can also do it to something like the 3-point arc if you have a curve or anything too. So let's do the 3-point arc. Do it on an angle. Now, click OK. Now go into your add relations and deselect the arc and click the 2 endpoints. Click horizontal, and now you've made your 3-point arc horizontal. Click OK, and you've got your horizontal relationship with your 3-point arc. So for horizontal, you don't just have to use it on straight edges and straight lines. It can also be on a curve. Just get the 2 endpoints, make them horizontal to each other, and the whole sketch will follow around that. And that concludes our tutorial on how to use the horizontal sketch relations within SolidWorks. This is tutorial number 134, and it covers the vertical relation sketch feature within SolidWorks. Now to start off, let's open up a new part file. Let's click File, click New, click Part, click OK. Now in this tutorial, I'm going to be showing you how to use the Add Relations button and add a vertical relation to the sketch. So to start off, let's click line, click any plane, and just draw a line on an angle. Now click add relation, and it has the line already selected. Now again, there's two ways to do it. You can select the line or you can select the 2 points. The first one we're going to show is just by selecting the line. And when we click vertical, click OK, now we have a vertical relation with that line. And the vertical relation is parallel. If we call this the x-axis and if we call this the y, it's going to be parallel to the y. And if we do a horizontal like we did before, it's parallel to the x. Now let's draw another line on an angle. And let's click add relation. Let's delete the line 2 selection and let's select the 2 endpoints and make them vertical. Click OK. And now the whole line sketch is vertical now. And again, with this one, it doesn't have to be just limited to lines. We can do a curve like the 3-point arc again. So let's click the 3-point arc. Let's click a point there, click a point there, click OK, and let's add a relation. Now delete the arc, and let's select the 2 endpoints, and let's call it vertical. Click OK, and now our whole curve is vertical. So this just shows you that you're able to do lines and you're able to do curves that are vertical, and when you do the vertical, it's going to be parallel to the y-axis if you look at it as an x and a y. So this just shows you how to add relations to the sketches by adding a vertical relation. And that concludes our tutorial. This is tutorial number 135, and it covers how to add a collinear sketch relation within Solidworks. Now to start off, let's open up a new part file. So let's click File, click New, click Part, click OK. Now in this tutorial, I'm going to show you how to add a collinear sketch relation, and we're going to add a few lines in, and by using the Add Relation button again, we're going to add a collinear relation between the two. So to start off, let's click Line, click Front Plane, and let's add a couple lines in here. So let's do a couple that are on an angle. So let's click Add Relation, and let's click this first line here, and let's make it horizontal. Click OK. Now we're going to make this line, we can just click horizontal if we wanted to, but let's say that this was actually at a certain angle. Let's make this one collinear to this. And what collinear means is that they're both running in the same line together. So let's click Add Relation, click this line, and click this line. Click collinear. Now both of them are running in the same path as one another. They're both collinear to each other. So let's click OK. Now let's do 2 that were on the angle and make them both collinear. Now let's select these 2 lines, click collinear, click OK, and now they're collinear to each other. So collinear just brings the 2 sketches, whatever they may be, in line with each other, just so that they're both in the same line. And then if you had, say, some other stuff running around, like, let's do an example such as this. So let's put one angle here, and let's put another one there. Now let's put a couple 3-point arcs on here. So put one there, and put a skinny one on this one on the other side. So click OK. Now say that we wanted these 2 sketches to run collinear to each other. All we'd have to do is click Add Relation, delete the arc there, click the 2 straight lines, click collinear, and both sketches with all the extra stuff that you've added on the side, they follow each other. So now these lines are collinear, and the, I guess you can call them like the secondary lines that we've made around here, they also follow the attached line, and it just creates a relationship between the 2. So let's click OK. And now I'll just show you another one. We can do it with, say, like a rectangle. So let's draw out a rectangle here, and let's draw a line over here that's on an angle. If we click Add Relation, we can click this line here, and we can make it collinear to any of the lines here. So first let's do this line here, click collinear, and now it's collinear with that one. Now let's say that we wanted one that's collinear with a vertical line. So let's draw another line out here. Click add relation to this one, make this one collinear, and it makes a collinear relation with that vertical line. Click OK. So using these examples, I've just shown you how to add collinear relations and how it's not just like the one line moves, like in this example here, the whole sketch with everything else related to it also moves to satisfy the collinear relationship. So that concludes our tutorial on how to use the collinear relations button within Solidworks. This is tutorial number 136, and it covers how to use the perpendicular sketch relation feature within Solidworks. Now to start off, let's open up a new part file. Let's click File, click New, click Part, click OK. So in this tutorial, I'm going to show you how to add a perpendicular relation to any of your sketches. So again, we're going to be using the Add Relation button. So to start off, let's throw a couple lines in there. So let's click Line, click the front plane, and let's make one line just vertical, and we'll make another line just on an angle on the side here. So if we click Add Relation, and if we select the two lines, we can click Perpendicular, and if we zoom out a little bit, you can see that the two lines are perpendicular to each other. Now, perpendicular, again, it means that one line is 90 degrees to the other, so just like it shows kind of in the preview in the side, that's what your result will be between the two. So let's click OK. Now, again, I'm going to make a couple that have features on them, so I'm going to make a couple lines on angles. And I'm going to add a couple relations to them. So now if I go and try to make a perpendicular relation between these two lines, everything else is going to follow them. So if I make this line and this line perpendicular, if I zoom out, you're going to see that even though that guy's way out there, but it's still perpendicular and everything follows each other. So the relations here, this one stayed in place, but the relations here, the 3-point arc still follows this one as it's still related to that, and this line here just received like a new relation, so it moved around. Now let's do another one. Let's insert, click Tools, Entities, click Polygon, and let's do a 6-sided polygon. And let's do a rectangle. Now let's throw a couple lines in. Throw one line in here, and throw one line in over here. Now let's add a couple relations. Let's add this line relation to this side here. So let's click this side here and make it perpendicular. And you can see that we've made this line perpendicular to this side of the polygon. Now let's do it with the square now too. So let's click OK, click Add Relation, click this line here, click this line here. Now we have all the other ones selected too, sorry, so delete all the lines, start from fresh. So click this line here, then pick perpendicular, and we made another perpendicular relation between these two here. Click OK. And that's how you add perpendicular relations to your parts here. So just remember, when you're doing perpendicular, it's just a 90-degree one, and a collinear, if you look at like the two lines, it's like 180 degrees, or a 0 degree, whichever way you want to look at it. And that concludes our tutorial on how to use the perpendicular sketch relations feature within Solidworks. This is tutorial number 137, and it covers how to use the parallel sketch relations feature within Solidworks. Now to start off, let's open up a new part file. Let's click File, click New, click Part, click OK. Now, like the other tutorials, I'm going to show you how to add relations and use the parallel relations feature. So to start off, let's do a couple lines again. So click Line, click Front Plane, make a couple lines on a couple angles, click End Chain, and let's click Add Relation, and let's click each line, and let's click Parallel. Click OK. And now we've created a parallel relation. Now, the parallel is pretty much the same as a collinear, except that there's a distance between the two. So then you're able to go and say, I want the distance between these two to be, say, 150, and you'll get it. Whereas in the colinear, it's there's no distance between the two, really. They're on the same line, so they're just kind of like a distance of 0, but this line's kind of like able to move up and down. So that's kind of like the difference between using a parallel and a collinear relation. So the parallel, you're able to have a distance in between the two like that, and a distance like that. Whereas with the collinear, it's only a distance up and down, not side to side. So let's do a couple more. Let's throw in a rectangle. And let's add another line on an angle. And let's add a relation between that line and that line. Let's make them parallel. Click OK. And now we have a parallel line to that line there. So it's just like all the other ones, with the other ones that we had as like the colinear. It's the same as a colinear. It's parallel 0 degrees, or if you want to call it 180 degrees between the two. And the only difference is you can have a distance between here and a distance up and down. Whereas a colinear, again, it's only a distance up and down, not side to side. Now let's do a couple sketches with a couple other things on them. So one line there. And let's make another line there. Click 3-point arc. And do one over here. And let's make these guys parallel again. So click this line, make it parallel, and again, the other features related to it follow. So if you have a large sketch and you create a parallel relation between a couple, they're going to follow. So let's click OK. And let's add another parallel relation between this one, and all of these will still follow again. So click Add Relation, click this line, make them parallel, and these guys are going to follow again to be parallel with that. Click OK. So you can see sort of how one relation goes down the line and still affects all the other relations too. And that concludes our tutorial on how to use the Parallel Sketch Relations feature within Solidworks. This is tutorial number 138, and it covers how to use the Equal Sketch Relations feature within Solidworks. Now to start off, let's open up a new part file. Let's click File, click New, click Part, click OK. Now, what we're going to be doing again is using the Add Relations button, and with lines and different sketches, we're going to be able to make certain lines and certain distances equal to one another. So to start off, let's sketch out a couple lines. So let's click Line, click Front Plane, and let's just make a couple lines that are in line with each other. And let's make these equal to each other. So making them equal is going to make the distance that both of them are equal. So let's click Add Relation, click this line, and let's click Equal. And now both of them are equal height. Click OK, and we have two equal lines. Now we can do this to other objects. So let's say that we've created a rectangle. So just throw one in there. And you wanted to make it a square. All you have to do is click Add Relation, click Equal, and it'll give you a square. Click OK. So this way is a lot easier than clicking a smart dimension and going around and doing each dimension. So you just make a square, click Add Relation, Equal, and you get it. So, but you're still able to, after you make it, say you want the square to be a 50 by 50, type in 50, and the relationship is distributed all the way around too. Now another quick way of doing an equal one is if, say, you make a triangle. So make three lines that are not equal. So right now you have a scalene triangle. So say you want to make a isosceles triangle. That's a triangle with two equal sides. Let's click Add Relation, click two of the sides, click Equal, and now you'll have an isosceles triangle. Now, let's say we want to make an equilateral triangle. Then we have to click the last line, click one of the other two lines, click Equal, and then you have an isosceles, a equilateral triangle. So all the sides are equal, 60-degree angles. Click OK. And again, if we use a smart dimension, we're able to go in and say we want to have a 60 by 60 by 60, and you get 60 there. This is going to be 60. And this is going to be 60 also. And that's how you use the equal sketch relations feature within SolidWorks. This is tutorial number 139, and it covers how to use the fix sketch relation feature within SolidWorks. Now to start off, let's open up a new part file. Let's click File, click New, click Part, click OK. So in this tutorial, using the Add Relations button again, I'm going to show you how to fix a sketch within SolidWorks. Now, why you would want to fix a sketch is if you want it, when you're adding relations and whatnot and everything else to it, you want it to remain in that place. So once you fix a sketch, it doesn't move. So when you say add a relation to another sketch with it, that sketch is going to stay in place and the other sketch is going to be moved. So to start off, let's draw in a couple circles. So click the front plane and let's just draw a couple circles and just make them in line with each other. Click OK. Now let's add a smart dimension from this circle to this circle. Make it 150. Now, as you saw, the circle on the right moved. Now, say that we want the circle on the left to move. What we would do is, first, let's delete this dimension. We will go into our Add Relation, click on this sketch, and click Fix. So now, if we click OK, this sketch is fixed in that position, and it will not move. So now, if we do the Smart Dimension, if we click this point and this point, and let's make it 200, now the circle on the left will move. And the circle on the left moved, the one on the right stayed in position. So by using the Fix feature, sketch relation feature, you're able to fix a sketch in a certain position that you want, and it will never move. If what this is really resembling is something like the origin. The origin is always fixed, so lots of times when you make relations to this, it will never move. It's always the sketch that's going to move. The origin never moves. The origin is always there. With fixing a component, that's pretty much the same as, you can kind of say that's what you're doing. You're giving it a coordinate system, a coordinate on the sketch, wherever it may be, and it's going to be planted there, it's going to stay there, and it's going to become like a reference for everyone else to move around from. Now, you can do this with more complex sketches or less complex, it doesn't matter, but fixing a sketch, if you ever have, say you have like a bunch of lines, such as that, and every time you go, let's make a dimension, so let's dimension this to be 20, and you don't want that whole side to move, you want the other side to move in, so press Ctrl Z just to go back. So what you'd have to do is fix this line here, so click Add Relation, fix it, click OK, add that same relation in there, make it 20, and now the other side's going to move. So by fixing a part of a sketch, you're fixing the sketch to manipulate it the way you want it to manipulate. So fixing a sketch, fix whatever part of the sketch right in that position, and you're able to reference and make the other parts of the sketch or the other sketches move in relation to that fixed component. And that concludes how to fix a sketch within SolidWorks. This is tutorial number 140, and it covers how to use the Midpoint sketch relations feature within SolidWorks. Now to start off, let's open up a new part file. Let's click File, click New, click Part, click OK. So in this tutorial, I'm going to show you how to use the Midpoint sketch relations button. And what that's going to do is through the Add Relations button here, when you have a sketch, you're going to be able to add a midpoint relation between a couple sketches. So to start off, let's click Line, click Front Plane, and let's make one line straight up and down like that. Click End Chain, and let's make another line like that. Click End Chain. Now what we're going to do is we're going to make this line going through the midpoint here. So to do that, you click Add Relation, click the line that you want to go put the midpoint through, and then click the point of the other line that you want to be in that midpoint. So we want this point to go through the midpoint there. So let's click that, click Midpoint, click OK. So now you have this point going through the midpoint in that sketch. Now you can do this with curve sketches too. So let's click this curve sketch here. Let's make a 3-point arc and click OK. And let's add a relation. Let's click this line here and let's make this point at the midpoint there. So let's click midpoint, click OK. And now it's added a relation between that point and midpoint of that line. Now if you change the dimension of the line, it's still going to follow. So if we make it 100, it's still going to be at that midpoint. If we make an angle in between these two, say we make it 80, it's still going to follow at that point. So when you add this midpoint, it's going to still relate to all the other dimensions that you put in there. So pretty much what you're going to be doing is you're going to have a line, and then you're going to have a point. So you have to relate that point to the line that you want to be on the midpoint. And that concludes our tutorial on how to use the midpoint sketch relations feature within Solidworks. This is tutorial number 141, and it covers how to use the Coincident sketch relations feature within Solidworks. Now to start off, let's open up a new part file, click File, click New, click Part, click OK. So in this tutorial, we're going to use the Coincident sketch relations button, going through the add relations to add coincident mates with our sketch. Now to start off, let's do a couple lines, sketch them out. So click Line, click Front Plane, draw one line straight up and down, and then let's do another line on an angle down here. Click Add Relation. Now this is going to be a relationship just like the midpoint relation. We're going to be picking a line, and then we're going to be picking a point. So pick this line, and then pick this point, and then click the coincident mate. Click OK, and you've created a coincident mate. Now what a coincident mate in this sense here is going to be is that it's going to be in line with that line that you chose. So this coincident mate is going to be able to move any distance from that line. So the thing is with when you do the midpoint is that it's subjected just to stay on that one point in the midpoint, but when you do a coincident mate, it can move any way up and down along that line. So let's do another line over here, and let's do a 3-point arc again. We'll do one on an angle, and we'll do an add relation. So let's add a relation between this line and that point there, make it coincident, click OK, and again this is able to run any way up and down that line there. And again, if you have other features that are related to it, it's going to follow those features. So just to show you, let's add another relation. Let's add this to this, and let's make them perpendicular. And you can see that the relations still follow using the coincident mate. So all the other mates, they still follow each other. And that concludes our tutorial on how to use the coincident mate sketch relations feature within Solidworks. This is tutorial number 142, and it covers how to insert a tangent sketch relation within Solidworks. Now to start off, let's open up a new part file, click New, click Part, click OK. Now to add a tangent sketch relation, we're going to be using the Add Relation button again, and a tangent relation is between a straight line and a curved surface. So it'd be between, say, a line and a circle, or say a line and 3-point arc or something like that. So to start off, let's click Line, click Front Plane. So let's sketch one line here, and let's sketch a circle over here. Now what the tangent relation is going to do is it's going to make this line tangent to this circle. So to start off, just click Add Relation, have the circle, have the line, click Tangent, click OK. So now you have a tangent relation between the two there. Click OK. Now this relation, it can go anywhere up and down the side. So you're able to dimension, say, from that point to that point, and say what the distance is. So right now it's like about 50. If we put it to 25, it's going to move. If we put it to 100, it's going to move also. So all the time though, this line is tangent, so it's just tangent to the curve or the circle, however you want to call it. So we can go back, and this can happen too with, say, if we put a polygon in. So let's click Tools, click Sketch Tools, and let's, oh, sorry, sketch entities, and let's pick polygon, 6-sided, let's throw one in, and then let's add a circle. And you can make that circle tangent to any of the sides on the polygon. So let's make it tangent to this side here. Click OK. Click OK. And now that line is tangent to this circle. So this circle, it can still move any way across there, but it's still always going to be tangent. And that concludes our tutorial on how to use the tangent sketch relation feature within SolidWorks. This is tutorial number 143, and it covers how to edit your sketch relations within SolidWorks. Now, if you already have sketch relations going on within your sketch, and you want to delete some of them and you don't like what's going on, rather than just deleting like the whole sketch, you're able to go in and delete each individual relation or edit them. If it's up to you. So first off, let's edit the sketch. And if we click the add relations, say that we want to change a relation between these two lines. So right now this point is a midpoint of this line. Say we want to change it that it's this point is the midpoint of that line. Click this line, click this line, sorry, click that point, and it'll come up with the relation. So right now there's a midpoint relation there. We don't want it, click delete, and you've deleted it. Click OK, and it's gone. So now let's make this point the midpoint there. Click add relation, click this line, click this point, click midpoint, click OK. So now it's gone onto the other side. Now say that you just want to delete the relations. You can either double click on the relation and click delete, and you'll have a whole view of the objects that you've selected. It'll show all the different ones that they have. You can click delete all, click OK, and now none of the relations on those two lines are there. Or if you want to, you can just click highlight one and click delete, and you'll delete the relation. So that's just the way to go in, edit, change your relations after you've already applied them onto your sketch. And that concludes our tutorial on how to edit sketch relations within SolidWorks. This is tutorial number 144, and it covers how to manually edit your sketches within SolidWorks. Now to start off, let's open up a new part file. Let's click File, click New, click Part, click OK. Now what I'm going to show you in this tutorial is we're going to create a sketch, and then from that sketch, we're going to manually move the points and lines around without actually using something like Smart Dimensions or creating references. So to start off, let's click Rectangle, click any plane, and just sketch out a square. Now to manually edit and change the sketch, what I'm going to do is I'm going to click the Select button, and you might have seen me in a couple previous tutorials do this just kind of like by nature without kind of explaining what I was doing, but say I want to move this line and move it up, all I have to do is click and hold, and then just drag it straight up. And then say I want to move this line here, I click, hold, and drag it across. So you're able to do it using lines, and you can also use points. So say I have this point here, I'm able to click and hold, and then move it around. And the sketch is going to move around too. Now I probably did this in a couple of tutorials before, and this is just kind of explaining what I was really doing. I guess like the mouse procedure, the clicks. Now I'll do another one. You can do a line too, so click line. Just draw a line out. Click the select, and you're able to select the whole line, move it up and down. You can click the point, make it go in and out. Now if you had it on an angle, you can move it any way that you wanted it. Now you're also able to do this with something like a curve and a circle. So let's click circle, and let's just create a circle. Now just zoom in on it a bit, and click the select. So with the center point, you're able to move it around anywhere. And if you click and hold on the outside, you're able to make it bigger, smaller, whatever you want it to be. So the reason behind why you would want to manually move around dimensions yourself is if you're in a situation when you have kind of like a little profile and you have a bunch of different lines, you want to kind of move it around yourself before you use the smart dimensions, because when you throw in a couple dimensions, you might actually really kind of like screw up your sketch. So I'm just going to show you a little example. So say I had a sketch such as this here. And say I know that once I put a dimension between this point and this point, whatever, just as an example, it's going to screw up the profile of this sketch. So instead of throwing in that dimension, and I know it's going to mess up what it's actually going to look like, because say I might have some lines such as this, like overlapping after I put in the dimension. Instead of putting in the dimension there, I'd actually just raise all this up and then put the dimension in to move that line up. But if I didn't do that and I put the dimension in and say everything was like this, there's no possible way to dimension these lines to go back on top of here. Because when I'm putting a dimension in here, I'll just show you, between here and here, there's no way to flip this line onto that side. So, you know, I'm doing 15, it's going to move 15. If I put negative 15, it's not going to accept it. It needs a positive number. So the only way of actually moving that line on top there is by physically moving it up. So just by manipulating some lines like this, you're able to make sure that the sketch and the profile that you're trying to make is going to be correct, and that you don't run into a situation such as this where the lines are overlapping and you're able to do nothing. So that concludes our tutorial on how to manually adjust sketches within SolidWorks.